Okay, so 10.4 is all about conditional probability. So, for there at the top of your page, conditional probability contains a condition that may limit the sample space for an event. You can write a conditional probability using this notation. The way you read this, remember we said the P stands for probability and the parentheses stands for of. So this is the probability of event B once you have already been given event A. So basically you have to determine what's left for you to use in event B after you have already looked at what event A limits you to. Okay? So basically whatever is listed second in this parenthesis is actually what is going to need to be looked at first, because it's going to restrict what happens for B. Does that make sense? A restricts B. Alright. Everybody have this? Part change? What have you been doing? You can get it in school. Alright, so first example, it says that the table shows the results of a class survey. Find P, or probability, of owning a pet that's been restricted by being a female. Okay, so like I said, remember this part is what restricts the first part, right? So how many total females do we have? 14. So I don't care about the males because it's been restricted to females only. And then I want to know how many of the 14 females might own a pet. 8. So our probability, because of this, would be 8 over 14. So like you guys said, there were 14 females total. 8 of those own a pet, which gives us 8 over 14. Okay, so again, make sure that you're paying attention to the fact that we look at this part first, and that determines the second part. Okay? All right, everybody have that ratio written down for that problem? Okay. All right, this next one says the table shows the results of a class survey. Find the probability of a male that washes the dishes. Okay? So remember, this part is what we're looking at first. How many people wash the dishes? So how many people said yes to washing the dishes? 14. Okay? So the condition, wash the dishes, automatically limits our sample space to only the people who said yes, which was 14 total. Okay? Then we look back, how many of those are male? 7. So of the 14 that wash dishes, 7 of them are male. So the probability of a male that washes dishes would be 7 out of 14.
Would it be out of 15?
Wash dishes first. How many people said yes to washing dishes? 14. So it's out of 14. 7 of them were male. So that's why I said, make sure you really pay attention to the fact that you look at this part first. The second part determines the first part, okay? All right, so I don't think this next one's on your paper, so I want you to just follow along with me up here on the screen. Okay, it says, using the data in the table, find the probability that a sample of not recycled waste was plastic, or the probability of plastic was non-recycled, okay? The given condition is going to limit our sample space to what? What was given? Non-recycled. So the given is always the second thing. So if I'm looking at only the non-recycled, I'm looking at only the second column, right? So how would I come up with the total for that non-recycled? All right, just add up all those pieces. Okay? Then we go back and decide how much of that is going to be plastic. Okay? So for our non-recycled, like you guys said, we're going to add all of these up. And in that non-recycled, we're looking for how much of it was plastic. So I can't even look at this column anymore because it wasn't part of non-recycled. I'm only looking at plastic in the non-recycled column, which would be that 20.4. Okay? So this would end up being 20.4 over 156.3. If I go ahead and divide those, I get about 0.13, which would be what as a percent? 13%. So the probability that a non-recycled waste was plastic is about 13%. Again, let me reinforce, the given is the second thing in your parentheses, right? So look at that part first, then go back and look for your favorite outcome, okay? All right, so now let's look at our formulas. So in our old material, I believe it was on 10.1, or maybe, I can't remember, 10.1 or 10.2, when we talked about coming up with our formulas, I believe it was 10.2, for any two independent events, A and B, from a sample space with the probability of A does not equal 0. Remember, our formula was the probability of A and B was equal to the probability of A times the probability of B, right? That's what we learned back in 10.2. But for what we're talking about today, for any two dependent events, A and B from a sample space with probability of A does not equal 0, is going to be the probability of event A times the probability of event B dependent on A. So again, we look to that second piece first to restrict what B could be. All right, so make sure you have both of these formulas written down there on your paper. Hey, and if you guys remember on 10.2, when we were coming up with our probability, we had a fraction on the assignment. They asked us to convert that into a percentage. So here we are looking for some percentage, okay? Does everybody have their two formulas right down here? Okay. All right, so our next example says that researchers asked people who exercise regularly whether they jog or walk. 58% of the respondents were male. 20% of the respondents were males who said they jog. Find the probability that a male respondent jogs. Okay? So, for the probability of it being a male, they said that was 58%. Okay? The probability of it being a male who said that they jogged was 20%, right? That's the two things they gave us here. Okay? So, this being the first thing, the fact that it's a male is like our event A, right? And this over here would be our event B. So, A is going to determine male, B is representing that they jog. So, according to that formula that we just wrote down, we would have the probability of A and B is equal to the probability of A times the probability of B given A. All right. So, the probability of it being A and B, male and jogs, what did they say that was? 20%. So basically what I could do in this equation is replace where it says probability of A and B on this side of the equation, I could replace it with 20%, okay, which would be 0.20 as a decimal, okay? They also told us the probability of A was 58%, so I could replace this part in the formula with 0.58. So the only part I wouldn't know would be the probability of B given A. So we substituted the 20% in for the and. We substituted the 58% in for the A, the male. I'm looking for this piece here. So how would I get this piece by itself? How would I get the 0.58 to the other side? Divide. Divide both sides by 0.58. So I would have 0.20 divided by 0.58, which is a decimal of what? What do we get when we divide those in our calculator? Right. Which would be about what percent? 34%. Very good. The 0.344 as a decimal is about 34%. So the probability that a male respondent jogs is about 34%. All right, and we should have one more example to look at. So once you have this one down, if you will flip it over onto the back, we got one more. Okay, the next one says that researchers asked people if they drink soda regularly and whether they prefer regular or diet soda. 40% of all respondents were people who said they drank and preferred diet soda. 60% of all respondents said they drank soda. Find the probability that a respondent who says they drink soda drinks diet. So, the reason we're having to solve this is because obviously there were going to be some people who responded and said they don't drink soda at all, right? And they only gave us information for soda drinkers. So what we're trying to figure out is out of everyone who responded, not just the people who said they like soda, how many drink diet soda, okay? All right, so the first percentage that they gave us was 40% of the respondents said they drank and preferred diet soda. 60% said they just drank soda. So which one of those is more of an overall? The 60 or 40%? The 60, because they're saying all 60 of those people are drinking some type of soda, right? So my first event, probability of drinking a soda is 60%. While the probability of them drinking soda and it being a diet soda, they told us was 40%. Okay, so remember, A is my overall or my more general statement or my given. So my given here is the drinking soda is 60%. So this is going to be my event A. The likelihood of these both happening is our event B. Okay, so drinks a soda is A. The fact that it's a diet soda is B. All right, so same formula that we just talked about. The probability of A and B is equal to the probability of event A times the probability of event B given A. So again, I'm just going to go in and substitute what they gave me. So what can I plug in over here for probability of event A and B? For A and B. Guys, A and B. What one matches the colors? Like we color coded it here. 40%. A and B. A and B. 40%. The probability of A. 60%. So plug those in. Okay, again, we're trying to solve for the probability of event B given A. So what are we going to do? Divide. So we end up with 0.4 over 0.6, which is what is a decimal? Right, 1/6 repeating, which would be about what percent? 66.7 or 67%. Very good. So the probability that a respondent out of everyone that they talk to drinks diet soda is the 66.7%. Okay, again, so we set it up this way, guys, so that it would make it easy for you to determine what goes where. Overall, 60% drank soda. Right? This is a lone event. Nowhere in this does it say and, right? Here, the fact that they drink soda and its diet was 40%. So when I come plug that in, this one has the word and, this one has the word and, they're the same. Plug it in here. Here, it's a lone event. So you plug in your 60% here and then solve.